Just trying to repurpose a capacitor here that the negative lead broke off on. And I think that will be successful. And this is where the two 8 microfarad caps, and I'm going back with 10s, actually connect. And you'll recall the negative and positive polarities come together at that point. I'll get my meter out, clean around this with some alcohol, and just make certain that I got a good connection. But you can see that the negative polarity in this direction of the arrow connects to the positive side of this capacitor. The other thing that I do, and it's just a personal preference, is take some sandpaper and lightly sand up the terminal strips before applying solder. I've just found at times they seem to have just a little bit of buildup on them, and you just don't get a good solder connection for some reason. Just check here just to make sure that I got a good solder connection. And I do. I just wanted to make certain. Alright, just getting a little heat shrink here on the capacitor leads. Here's a little bit of a dry fit here on the terminal strip that I'll be using. What I'll do is get my glue gun out and just hit it a couple times right here just to hold this top capacitor in place. Alright, let's get this soldered up here. Okay, here's a look at the electrolytics used in the B+ side, and you can see what I try to do is not block the view of the capacitor value as well as the polarity. So if I'm back in here troubleshooting, or someone else in the future, you can easily see the polarity itself of the electrolytics. Then I'll go back to the other side and put just a bit here as well. I'm not one that's typically a big fan of drilling holes in a chassis. Try to use an existing location, but this thing is so cramped. I don't have a choice. I've already got something marked right here, and it will be in line with the other two holes that has a ground connection that runs across the top side of the chassis, so I think the fastener will be out of the way. This will give you an indication what everything will look like once it's mounted. And I've still got clearance here from underneath the chassis, and that leaves me a little spot here that I may mount the power resistor and the diode as well. Okay, a little 9/64 bit there, and it's perfect here for a number 6 32 by 1/4 inch screw. And I'll use a little lock washer on it as well. Let's get this mounted. Okay, I think that's got it nice and secure. Plate number 2 is right here, pin 1, pin 2. So let me clean up this connection here. This is the red lead that ran over to the capacitor bank. It's not quite long enough, so let me just run a new red lead over. This one wire here that's probably about 3-4 inches long. I'm going to go ahead and place a new conductor here, just a little bit longer than what was there, and go ahead and solder it up there to pin number 2, which is the plate there. And I think this is going to actually attach back to that resistor network, but at least it'll already be soldered up and be in place. Okay, another connection made there. Just to recap, coming off of plate number 2, which is pin 2 off the 25Z5, and that just routes back over here to the capacitor bank that I put in. Schematic called for a 8 microfarad cap, and I went back with a 10, and it attaches itself to the negative lead. A red lead was used in the past. I went with a blue lead, and the remaining positive connections will be with red. Let me get in here and just clean up pin number 4, the cathode of the 25Z5. I want to remove this short jumper. That jumper went back over to the switch, which has since been removed. Then we'll run the brand new B plus lead using a red conductor back over to the 10 microfarad capacitor as I just called out on the schematic. You may notice I left just a bit of tail right here on this lead after going back through the terminal strip, and that's by design because I'll have some additional tie-in points here, I do believe, so I'll cut that off later as needed. For now I'll go ahead and tack it in. You know, I wasn't feeling my best when I shot that first series, and this is kind of in the middle. You can see I've done some more work, and we'll touch base here on the electrolytics in a bit, but you know, you just need to listen to your body. I should have stayed out of the shop a few days ago because I wasn't probably 100%. Anyway, it led to a simple mistake, but one that was corrected here in just a matter of a few minutes. I had came off of the 25Z5 rectifier to pin 5, which is one of the plates, and wired it directly back to the fuse holder. Well, that was a stupid mistake, and this should go back to the switch itself. So I've routed some wires here back under the chassis back over to the switch. I also took time to take the capacitor apart and get all this cleaned up, and tried to work around this coil here as well and clean it up. So everything here is I think complete, and I've double checked myself, so I don't think I've made any additional mistakes here. You can see I'm doing a dry fit. Here's one of the coils that has to be mounted back to the chassis here, and you can't see it, but in this area and this area I've got those little trimmer caps. They're very, very narrow, so I don't think that's a big issue. The great thing, these modern day electrolytics are much smaller, and you can see that leaves a perfect mounting location here for my power resistor, as well as my diode that I'll use to drop the line voltage down to best serve the heaters of the tubes. I was looking for a 53 to 65 ohm resistor. This is 56, so it's really, really close there in the middle, and I think that will serve me well. So what I'm going to do is do the same thing I did with the fuse holder. I'll be using a different epoxy. I've touched base on that before. That was a recommendation from one of my viewers and subscribers. Let me rough up the backside or underside of the power resistor as well as the chassis in this area. And let's go ahead and get this attached and mounted. And then we'll solder on the diode next and do those tie-in points. You can see I roughed up the chassis just a bit here using some 60 grit sandpaper in kind of a cross pattern, going this direction and then back this direction. And then this is the epoxy that I'll be using. It was recommended by one of my viewers. It's an Arctic Silver. I used it on one of my recent restorations. Seems to work well. It sets up quick also. So let me go ahead and mix this up, stir it up for about a minute or just a bit longer, apply it to the back side of the power resistor and get this in place. There's the epoxy mixed up there, just a nice thin coat. Alright, let's let that set up for a bit. You can see I've got the resistor mounted. We'll let the epoxy really tack up here before I do any soldering. And continuing a dry run here of the diode itself. I think this will work well. So what I'm thinking about doing is using this fastener location here. I'll take this terminal strip and I'll probably cut this end off here. Place it here, and my diode, if this is showing up, will attach between this pin and the power resistor here. And that should still give me room for the capacitors here. And I'll probably try to bend the diode back just a bit because it will generate some heat, and keep it away from the front side of the chassis. Let me go ahead and get this fastener loose. Go cut this half of this terminal strip off here that I don't need. Here's a look at the modified terminal strip. I cut this end off right here, sanded it down, and then I took some sandpaper here and cleaned up the terminal that I'll use for the diode itself and my connection point coming across here. In addition, I went on and took time to clean up the ground location, and I'll do the same here for this screw and go back with a tooth washer in this area also to kind of dig down into the chassis just in case I do need another chassis ground location. I'm sure I do, I just can't recall right now, but we'll have one available right here as needed. I'm going to go ahead and use two tooth washers, one on this side of the terminal strip and one here on the bottom side that would make contact with the chassis itself. And then on the other side we've got already a ground lug and a lock washer. So I should be able to make good contact here now with the chassis. I'll try to hold this where you guys can see that now. So that's fastened down here. Nice fit. Stays away from the edge of the chassis. This needs a few more minutes here. It's starting to tack up nicely. I think I can solder to it safely, but I think I'll exercise a little bit of caution here and wait, but we'll tie the diode between this point and this point. It's doing a dry fit here of the diode. And you really want to leave these lead lengths as long as you can. It's part of the heat dissipation. So let me see how I can best form these to maybe take advantage or leverage the majority of the lead length on each side. Here's a look at the 1N5408, and I was able to leverage the entire length of the leads without making any cuts or modifications. And you can see how I have it formed here. Let's see if I can get it back through here, and it will solder up as such. I'll try to zoom in on that so you guys can see it. And you can see I have the part number facing toward me. Let's go ahead and get some solder on this. For those new in the hobby, you may find this helpful. At times you're trying to get this outer dielectric off of your wire. And you can just put your wire strippers on here and hold the other conductor with a small pair of pliers and just pull straight off. A lot easier to do that versus trying to hold it in your hand. I've got the black conductor that's coming off of my switch and that's my hot lead with a 120 plus volts coming in to the diode here. So let me go ahead and get some solder placed here. Okay, I think we're safe here that we can solder this up now. You can see we're wrapping up here on the heater string wiring, and what I want to do next is tie in here to the power resistor back over to pin number 1, which is the heater of the 25Z5, and we'll be back right over here in this part of the circuit. And what I want to do is loop my wiring back away from the tubes themselves, and you can see my other input line here is also up against the chassis itself and away from the tubes. So I'll probably route this lead back around here and take that same course back over here to the heater, that being pin 1 of the 25Z5. I've got to get in here and clean up this connection point really well, and unfortunately I won't be able to show this on camera due to all this glob of wires here on top, but let me get this cleaned up, use some alcohol, resolder my new lead, and get it routed down here the back side of the chassis. Then we'll show the tie-in here back to the power resistor. Then when we get all this complete, we'll go back and just double check ourselves, make sure I haven't made any mistakes like I made a day or so back. May be hard to see, but I've got the new heater string wiring here wrapped around each other, and you can see I've formed it. I'm coming in up against the chassis itself just by my new capacitor bank here, and then my tie-in right here to the power resistor, and that tied in back over here to the 25Z5 pin number 1. Let me get this soldered up right here. Okay, that looks good. I had originally attached a red lead here to pin 6 of the type 43 tube, and that was just to mirror what was there before. But you guys recall I switched the polarity around, the plus versus the common side. So I changed that lead out to a black lead, and you can see I've got it cold around the others. And the connection point for that goes back to this bank of capacitors, and that's referenced as C19 and C20 on the schematic, and that's where the voltage doubler circuit occurs with these two capacitors here, where you have a negative and positive leads tied together. And then I had left a little bit of the lead out from the capacitor, and I'm just using the coil method there. So if I ever need to slip this off for doing any testing, I can do so with ease. Let me get this soldered up real quick, and then let's look back here at the other 10 microfarad cap that's out by itself away from the voltage doubler, and see what connection points we have there. If you guys recall, the original design had a paper cap being used as a safety cap, or what would be used as a safety cap today. So that's what I'll be placing in the chassis here, and you guys can refer back to my modified design. But I'll be connecting from this point here back over to here. And what I've done is fabricate a short jumper that I'll utilize to make the tie-in back over here on this capacitor bank. And then I'll wrap this longer lead here back around the diode itself. Let me get that soldered in. We'll come back and take a look. So we've got the safety cap in. Let's reference back to the schematic now. Let me go in and highlight everything that's complete at this point in time. And just make certain I haven't missed anything, and just see where a good leap off point is. Knowing that we still got to take care of the connections from this particular negative side of the 10 microfarad capacitor here.